Hello there, I'm Thomas Hatsios, a British American pilot flying the Boeing 777-300 ERX in the ninth flight. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport runway 14 for an Lszh localizer. Landing soon I'm in the cockpit for the pre-takeoff preparation of the PMDG simulation Microsoft Flight Simulator X Boeing 777-300 ERX. I'm gonna start showing you the cockpit instruments, the displays, and the functions of the Boeing 777-300 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director system panel, the radio altitude above the ground level, the magnetic heading and track, the magnetic north pole and true north pole, and magnetic variation depending on where we are in the world. We have also the barometric altitude above the sea level and the barometric pressure of the outside atmosphere. You can see the primary flight display here. Also, we have the target altitude selected from the autopilot flight director system panel and the vertical rate of climb descent of the aircraft intends 100,000 feet per minute. The vertical speed indicator tape that also shows the steepness of the angles the aircraft climbs. So descent, we have also the altitude indicator with the pitch ladder in degrees and the bank angle in degrees. We have the Lszh localizer crossbars and the autopilot crossbars for automatic guidance of the aircraft, and the flight director crossbars for manual guidance of the aircraft. We have the angle of attack of the aircraft at the flights and the flight mode demonstrator with the autopilot and the autothrottle. Later on in vertical navigation modes. We have also the navigation display. The navigation display that displays the GPS position of the aircraft, the inertial reference position, the terrain and weather reflections from the weather radar, the terrain map with the airports also. You can see the distance using the GPS. We have also the distance they are located with the distance rig and the magnetic heading and track, the magnetic north pole and north pole, again the magnetic variation. And we have other aircraft flying around our own aircraft in the navigation display over here. So we have the primary flight display and navigation display. So you can see the navigation display using the transponder, the AD-SPIN, ADC transponder, transmitter and receiver that transmits and receives from other aircraft and from our own aircraft. This calculates the altitude difference, the distance, the direction, the airspeed of other aircraft, and displays them in the navigation display like warnings. You will see the diamond shape of the other aircraft, and the tick assist and the traffic collision and alert system advisory warnings. So we have also the wind direction and speed and the ground speed of the aircraft. The next waypoint we're going to be overflying. Also, we're going to create a flight plan using the flight management computer, the FMC. I'm going to show you now. We're going to input all the data of the aircraft from takeoff to climb, cruise, descent, and approach. And this is going to create a flight plan or a route, complete route using a route planner creator of the flight management computer. So we're going to input the takeoff weight of the aircraft, that includes the empty weight plus the passenger and the cargo plus the trip fuel plus the taxi fuel plus the reserve fuel. We can input the flaps for takeoff, the flaps position for takeoff also. This is gonna calculate the center of gravity using the mean aerodynamic chord position, the Mach of the forward wings, and the horizontal tail of the aircraft trim stabilizer position for takeoff. So we're gonna have all this data for takeoff. Also, we're gonna insert the departure airport and runway. We're gonna select the runway conditions, the runway length, the runway slope, the wind direction, the barometric pressure, the density of the air and the temperature of the air. And we're gonna have other data also, like if the runway is dry, wet or ice. And this is gonna give us using the flaps and the horizontal trim stabilizer and the mean aerodynamic support of the center of gravity. Is gonna give us the takeoff speeds, the V1, V0, and V2. We're gonna see later how we're gonna calculate that for takeoff using the flight management computer control display unit. the FMC CDU. So we're gonna have also the departure sheets. These are instrument departures, intermediate waypoints and fixes from climb, cruise, then the destination airport, the descent and approach. We're gonna have the stars, the SIDER terminal arrival, waypoints and fixes, and the destination airport. And runway, we're gonna have also the ILS localizer frequency with the horizontal localizer and the vertical glide slope for guidance into the runway. Horizontal and vertical guidance either manually or automatically. You can see in the primary flight display also that. So you can see here, as I told you, the primary flight display, the navigation display, the flight management computer. We're gonna use for creating the flight plan and some data like the takeoff speeds. I'm gonna show you also the autopilot and flight director system panel, the upper and the lower ACAS display, the thrust levers, and the flight controls. So the autopilot and flight director system panel, the FTS, contains the autopilot engage and disengage switch, the auto throttle left and auto throttle right engage and disengage switch. The airspeed select knob, we're gonna select an airspeed, nautical miles per hour, max speed, nautical miles per hour, knots or max speed, and we're gonna have the modes for that, like the flight level change, the climb continues, or the auto throttle hold with the speed mode. So we have two main modes of airspeed command from the autopilot director system panel, and the auto throttle into the FADEX of the engine. The FADEX are the full authorities electronic control computers. One is the upper engine, I will explain it later. We have the General Electric 90G9200 engines installed in this aircraft. So I'm gonna select an airspeed. We're gonna be having either the fixed thrust mode or the variable thrust mode. So using during the climb, takeoff, go run, or climb, we have maximum continuous thrust, and this is a fixed thrust mode. Also during the descent of the aircraft, we have idle thrust, which is also a very fixed thrust mode. So in the fixed thrust mode, the airspeed is being adjusted by varying how fast the aircraft climbs or descends, using the horizontal trim stabilizer, the horizontal tail of the aircraft, trim position, or the elevator of the aircraft by commanding the autopilot flight director system panel or manually. So this will adjust the airspeed as we have fixed thrust. Also during the horizontal flight level of the aircraft, like the cruise or the approach landing, in which the aircraft altitude is held constant in flight, we have the variable thrust mode, in which the airspeed is being varied by varying the thrust commanded by the engine, by the FADEX of the engine. So we have these two main modes, as I will show you later. So you can see here is the airspeed select section. Here is the heading select section. Here is the vertical rate of climb, descent of the aircraft section, the airspeed, heading, vertical rate of climb, descent, the altitude select from the autopilot and flight director system panel. We have also the autopilot engage and disengage switch. So we have also the LNAV and the VNAV, the lateral navigation, the vertical navigation, which is interconnected with the flight management computer inputs and data. We have also the bank angle limit and the heading select, knob, the heading hold switch, the vertical rate of climb, descent of the aircraft, the VS or the flight path angle, which also determines trigonometric angle increase or the vertical rate of climb or descent in 10 times 1000 feet per minute, this mode. And we have also the altitude select knob, the altitude hold switch, and the VOR localizer, and the approach switch for the auto long function of the Boeing 777-300 ER aircraft. We have also the thrust levers. I will show you how you can adjust the airspeed, the thrust and the airspeed, either one, using the thrust levers and the altitude of the aircraft inside. So you can see here the thrust levers we use for this. We can move forward and aft, and you will see also the data here of the engines in the upper and the lower ACAS engine indication crawler system display. You can see all the data of the engines. We have also the flaps here, the slots, other things. I'll stop now in a couple of seconds. So we have also the flight controls. I will show you now the flight controls of the aircraft. We have this the control column and the control wheel. So the control column is a part of the yoke of the Boeing 777-300ER. It controls the horizontal tail elevator, up and down movement, so you can climb and descend the aircraft in flight. Also, the control wheel controls the ailerons and the spoilers in the left and right wing, so you can bang roll the aircraft either left or right turns, and you can use also the rudder pedals for the vertical tail, the rudder of the aircraft. So I use this side stick, the Lszh Extreme 3D. You can see here. So using that for controlling the control column, you can see here for controlling the tail of the aircraft climb or descend, and also bang roll left and bang roll right. You can see both sides are interconnected, the left and the right side, so you can steer the aircraft. You can use also the rudder pedals left and right, so you can see also both sides. You can see also the thrust levers here. I use these to move the thrust levers forward and aft. So I have control of the aircraft like this in flight. I can change the direction. So you can see the side stick deflection is proportional to the yoke deflection. You can see also the rudder pedals and the horizontal trim stabilizer. This is how you control here the flight controls, the movement. We have also the nose steering in the ground. So I will show you now also the outside view of the flight control system. You can see the side stick deflection is proportional to the yoke of the flight controls deflection over here, as you can see. So you can leave also neutral, or you can make small corrections or bigger ones, depending on what you want to do the aircraft in flight. So I will show you now the outside view of doing the same thing, the side stick deflection. So you can see also the speed brakes extend. You can see the side stick movement like this. You can control the flight controls of the aircraft. So you can climb, you can descend, also make bang roll left and bang roll right, and also the rudder pedals, the vertical stabilizer like this. So hope you like all these things about the flight controls over here, how you can control the aircraft in flight with full side stick movement, proportional yoke. And also now I'm gonna show you The overhead panel, I will explain you the function of the systems, like the electrical, the hydraulic. So we have the electrical over here, the hydraulic system, the pressurizer system, the fuel system, the electronic engine control for the engines, the ADIRU, the air data units, the reference unit, the controls for the air data display, the GPS and other system, the attitude indicators. So we have in the overhead panel the primary flight control computers also. So you can see we have the electrical, the left engine driving and the right engine driving, IDG, the great drive generator, the backup generator, the battery, the primary flight control computers, the ADIRU, the air tunnels reference unit, the circuit breakers of the aircraft. This is the lighting system, the windshield wipers, and also the passenger oxygen over here, the rammer turbine, the hydraulic system, the left engine, right engine driving, also the electronic engine control for the engines and the auto start system, the fire control, fire extinguisher, also the fuel dump. You can dump some fuel in flight, and this is the left and the right wing fuel tank, the center tank, and the fuel booster pumps, and the crossfeed valves for the fuel tanks. Also we have this can balance the fuel between the left and the right wing, the crossfeed valves. Also we have the cabin pressurization system, the wing and engine, the ice over here, the cabin pressurization, the outflow valves. You will see also in the system page. Also we have the bleed air pressurizer we need for starting the engines, and also from the engines for hydraulic fluid pressurization, wing and engine the ice, air conditioning and ventilation, and also for cabin pressurization. I'm gonna show you also that. So this is the Thomas Hatsios, German-American pilot flying the Boeing 777-300ER in tonight's flight. Thank you very much for joining me. I will start showing you now the systems, and I will make an engine start demonstration. So I will show you also the complete flight from takeoff, climb, cruise, descent and approach, and landing. So I'm gonna start with the systems explanations, and I will start with this over here. So we can start with this over here. So we have here so you can see also another nice view of the aircraft outside, and we start now the systems explanation. So you can see here is the primary flight display and the navigation display. You can see we have the airspeed indicated over here, the airspeed tape, we selected from the autopilot, the director system panel, the ground speed, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the radio altitude above the ground level, the magnetic heading over here, and track the magnetic north pole. Magnetic variation depending on where we are in the world. We can change that either through geographic north pole or magnetic. Here we have also the distance. You can see some aircraft flying here, 1, 2 or more aircraft. You can see the diamond set here is plus 2,200. this is plus 9,900 feet. It's getting closer, so you can see in the radar the aircraft are coming closer to you. So you can see one aircraft coming here in the navigation display. We're gonna see the warning in a couple of seconds. So here we have also the altitude indicator with the pitch ladder in decrease and the bank angle in decrease, the flight director and the autopilot, the display, the LNAV and the VNAV, the angle of attack of the aircraft as it flies, the altitude gauge and the airspeed as it takes, and the vertical speed indicator. This is the primary flight instrument. You can see also the vertical rate of climb descent of the aircraft with the vertical speed indicator. You can see this needle moving up when you climb or moving down when you descend, so you have to pay attention to that to know whether the aircraft climbs or descends, not this indication, which is only the pitch altitude of the aircraft in flight, not the actual flight path. So you have also the flight mode annunciator with the autopilot and the auto throttle. Later on vertical navigation modes, the tick marks of the degrees of the pitch of the aircraft for the bank, like 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 degrees. So you can see the pitch altitude like plus 20 or minus 20. So you can see also the navigation display here. We have the oncoming aircraft. You can see the diamond shape here. The aircraft coming in is plus 300 feet. You can see the warning here of the traffic over here in the display. So this aircraft is very close now to us. You can see it is coming through. It is coming for landing over here. It just came in. So we just spotted one aircraft in the navigation display using the transporter. So you can see also other aircraft in a different distance over here, a couple of them. If you change the distance ring, you can see also we have the transporters here in the radio and communication panel. The ADC and ADC transmitter receiver. You can use you can change the frequency here. You can see also the traffic collision alert system, the warning. We have, so this is the radio and communication panel, and this also is the weather radar. You can see the reflections here in the navigation display. So we can use also, we have now the true north pole over here. The geographic we can change to the normal, the magnetic now, north pole. So you can use other magnetic or true. We have also the barometric pressure. We can set the barometric pressure in inches of mercury. The meters also display using the FS panel, electronic flight instrument panel. So we have the target altitude in meters also, and the altitude of the aircraft. So we can also set a couple more things. I will talk to you about the autopilot, flight director system panel, the FPS now. So you can see the auto throttle left. We have the auto throttle left displayed here. And, the APPRACH sense indication throttle system display. You can have the auto throttle right or both off or on. So we have the auto throttle right off now. You can see here. We have the flight director on and off, flight level change. So both flight directors cancel this mode. So this also you can see is depressible. You can change the indicators, speed or Mach, the auto throttle, the LNAV. So this you can set on airspeed. I will set one for after takeoff for climb, like this, 253 nautical miles per hour. We have the autopilot engaged like this. Speeds autopilot disengaged like this. One more time. You will see the warning also if I press this out. You will see here the warning coming in. and we have also over here the autopilot is disconnected with the red letters. You can see autopilot disconnect. So we have to reset the autopilot here. We can set also flight level change, airspeed, the altitude of the aircraft as we cruise, like 35,300, the bank angle of the aircraft. We will set auto, and the heading we will set all track. For the runway we're gonna use for takeoff, heading and track. We'll set either altitude, hold. So now we have the flight level change with the autopilot here. So you can see heading, hold, flight level change speed. This target airspeed 253 knots or 9 miles per hour, and this target altitude 35,300, 7,700. From this altitude elevation, it's our runway. We have 1013 hectopascals in the magnetic setting for navigation. So we can change again for ranges of Mercury 29.82 for the barometric altitude. We have also the other the altitude over here. Hold switch. We can set also that. This also the first one. So we set the altitude. It will display like this. Altitude with the autopilot or the flight director, either one. Then hold autopilot on. We can set the autopilot off. We will see flight level change, speed with the flight director and heading hold. So this is the manual mode and the altitude also. So we can set again the autopilot on. Set also this mode for the vertical speed. You can see the climb, descend, determine the trigonometric angle and decrease. So we can use this slider. Like -3.5 degrees, you will see the negative sign. -3.5 degrees descent over here, and you will see the pitch ladder -3.5 degrees, heading, holding, flight path angle. So this is gonna give us a descent from the cruise altitude over here. You will see you have to follow these tick marks, the purple. So we make this a climb. We'll set it the other way for a climb like this. So you'll see the positive now sign. You will see the value increasing, +3.5 degrees. You can move the cursor up and down and fix this for the autopilot navigation or manual navigation. You use the flight director flight path. So we have here the pitch altitude displayed with the purple indication. So we have only one mode left. We have also the VOR localizer here, and the approach and autolan VOR approach, and also we have the vertical speed like this in tens, hundreds and thousands of feet per minute for descent or climb of the aircraft, like this -3,500 feet per minute. So this is gonna make a descent over here. So you will see you have to pay attention to this the vertical speed indicator, descend like this with the purple indication over here. This tick mark, it signals descend with the vertical speed mode over here. And also we have the climb over here mode. So we have to move the slider the other way, it will give us a climb. for this mode, this light on plus 3,500 feet per minute. So you will see the plus 3,500 feet per minute over here for the climb mode. So we can use also another way to disconnect the autopilot and flight director system panel. Press this switch one time if the autopilot is disconnected in the control wheel. You will see again the warning, and now that the autopilot is disconnected over here, the red letter, and also we have press one more time and we will confirm the autopilot disconnect action. So you take manual control of the aircraft. We're gonna have another aircraft coming in. It's 20 nautical miles away, just put it up over here with the diamond shape plus 3,000 feet of the runway elevation. Is about 17.5 nautical miles in this direction. So we're gonna have also what else we can do. So we can also see the flight control side. Also we have the horizontal trim stabilizer over here. The horizontal tail of the aircraft picks up and picks down. The rudder pedals, the aileron trim over here, and the rudder trim and the aileron trim set here. So you have to set the horizontal trim tail. We have also the auto trim of the autopilot and flight director system panel. If we have a failure of the hydraulic system here, the CODR, C1 and C2, you see the pressurized, the autopilot and the auto throttle will lose the control of the horizontal tail auto trim system. You have to turn off the switch CNR fail. You see this stop. You have to turn from the normal to cut-off. You will lose the auto trim function from the autopilot and flight director system panel. You have only the manual trim order. So this is not gonna have an auto trim. It's gonna have only the manual trim here. The trim tab picks up and picks down like this. You can see and set here the degrees you need of the horizontal tail. So you can see the green bands for takeoff and flight conditions, how many degrees you pick up and pick down. And you can use also this tab to move up and down the horizontal tail stabilizer and this manually. So we'll close this switch off. So you can see the horizontal tail trim stabilizer with this whole horizontal tail movement up and down. You have also the elevator up and down like this, which is part of the horizontal tail. Here you have also for the ailerons and the spoilers the trim system. So we see the aircraft is coming in here. You can see also in the radar display over here is plus 2,500 feet, and it's closer 5 nautical miles, so multiplying the 1085 plus 2,300. You can see the arrow down means it's descending, but it's still plus 2,200 feet above us, and it's 5 nautical miles. And we have one closer up here in the runway. So this is gonna be in a couple of minutes. We have also other things to see. We have the flap up and down movement. This is the flaps position. You can extend and retract over here. You will see the flaps position. The landing gear up and down. Some things you have to know. The flaps extender, retracting the landing gear, the alternate gear, lock override, some other functions. The flaps also limit and the auto brake function here. Some switches, so you have rejected takeoff and maximum. You can see the trademark of the aircraft. So this is the displays over here. the upper and the lower ACAS engine indication controller system display. You can see the engine indication, the N1, which is the low speed starter and sub-low pressure compressor and turbine of the tube contributed engine. You can see some warnings about other systems, the exhaust gas temperature per engine. We have the left and the right engine, the bleeder, the pressurizer from the left and the right engine, and this is used for the cabin pressurization system. The total fuel on board the aircraft and the temperature of the fuel. You can see also we have the M2, this is the lower ACAS, which is the high speed starter and sub the high pressure compressor and turbine of the turbo contributed engine. And now we have the traffic here. We have the aircraft coming in. You can see in the display we just had spotted one more aircraft, so this is a good thing to have the display of the aircraft in the navigation display over here. You can track other aircraft coming in. So we have the N2, which is the high speed starter and the high pressure compressor and turbine of the turbofan engine, the fuel flow per engine per hour, oil pressure, oil temperature, oil quantity, and the vibration of the N2 states of the engine. We have also the thrust levers. You can see all these things. Move forward and after the thrust levers, you will see the indications change. This gives a signal to the fabrics. You can see it takes some time for the actual thrust lever position, and the commanded and the actual takes some time for the engine to spool up or spool down. You have to anticipate that inside. You can see we have also these switches, the auto throttle disconnect switch over here. You can disconnect the auto throttle and move the thrust levers manually in flight. The takeoff go around switch, the thrust levers. You can see the speed brakes also. You can move the speed brakes to extend and retract. So you extend when the thrust levers are at idle. Also, when you move the thrust levers, the speed brakes extend automatically. You can see the thrust reversers now that have been deployed, and they can slow down the aircraft after touchdown by reversing the flow of the bypass air from the engine. So you can retract, extend. You see the forward side of the extend and retract, and extend again like this. So this is something you use only during the touchdown and landing, or before takeoff if you wanna cancel the takeoff before V1. So also when you move, you have the speed brakes extended and you move the thrust levers forward, the speed brakes retract automatically, as you can see. So we have also the variable thrust. You can set one thrust lever at a time like this. You can see the right engine now is having more thrust. The left engine also both simultaneously. Left engine forward like this. Now we have the left engine more thrust with the right, and you hear the warning that will not configure for takeoff. So we have, as you can see, a lot of thrust. We have the General Electric 90 turbofan engine. So we have the General Electric 90 turbofan engines installed in our Boeing 777-300ER. Jet engines produce a lot of thrust. Also, they contain a lot of things like the fabrics installed in the gearbox. The fabrics are the full horizontal electronic control computers, one installed per engine, controls monitors the display, so the indications you see in the upper and the lower ACAS, engine indication control system display, about the N1. The N1 is the low speed starter and low pressure compressor and turbine of the turbo engine. The gross gas temperature per engine, the bleeder pressure from the 5th and 9th stage of the engine, fan stage, also the N2, which is the high speed starter and the high pressure compressor and turbine of the turbo engine. The fuel flow per engine per hour in thousands of kilograms or in thousands of pounds, the oil temperature, oil pressure, and oil quantity, and the vibration of the input stage of the engine. In the engines also we have the engine start, engine shutdown, engine failures, the fuel flow measuring unit, fuel measuring unit, and fuel heat exchangers, other sensors. Also the pressure inside the engine, we have another pressure inside the engine. The FADEX can command the outflow valves of the 5th and the 9th stage into a higher setting to relieve the pressure from inside the engine. Also we have another pressure that can close it and increase the pressure inside the engine. We have also the, you can see here, the thrust levers, you can see the upper and the lower ACAS. So we have also, as we climb the aircraft from the sea level all the way up to the cruise level, from 0 feet to up to 20,000, 30,000, 40,000 feet above the sea level, the air pressure, air density, and the oxygen level becomes less than half than that of the sea level as we climb higher. So also the airspeed of the aircraft is 2-3 times faster than that of the sea level. So we have different air intake from the front fans of the engines inside the turbojet engine for compression and fuel mixture. So we have a different fuel mixture request every second. So this is calculated also by the FADEX. And also as we descend from the cruise level back to the sea level, also we have a difference of temperatures. The temperature becomes freezing, like -30, -40, -40 degrees Celsius. So all these things that need to be calculated about the engines are done by the FADEX, including for these electronic control computers. One is called the engine. So it's the old panel doesn't send one, if one panel fails the other takes over. So it's a good thing to have the FADEX installed into your engines. Now I'll show you the overhead panel and make the engine start demonstration. We'll talk to you a little bit about the flight theory. We have some time. The aircraft about the newtons per second, velocity, max of motion, about the theory of fluids, pattern and nautical space engineering principles, and derive some equations about flight. So if we have time, I will show you how to calculate. So you can see the surface area of the wings holds the weight of the aircraft as the aircraft flies. You can see the vectors from the engines. The left and right engine is propels the aircraft forward. We have this vector is the center of gravity, and this is the lateral from the wingtip to wingtip. We have also the mean aerodynamic chord position, about 35% of the Mach. Over here is where the maximum aerodynamic lift in the wings of is also where the stall, the airflow becomes detached from the top of the wings, and we have the stall of the wings also. The center of gravity is transverse, it's somewhere here. You can see also we have the lever arm or moment arm is times the distance from the center of gravity all the way back to the horizontal tail or the vertical tail over the surface area of this flight control. So let the airflow of the air mass per second times the acceleration of the air gravity, and you have the lever arm or its arm tail. You can make climb, descend, and bank also. So we have the thrust, as I told you, from the engines. You can see using the Newton's physics and Bernoulli fluids, you can see the bottom surface of the wing is more flat. So as the aircraft accelerates for takeoff, the airflow of the air mass is having less airspeed below the wings, and also there is higher air pressure that pressurizes the wings of the aircraft up into the air. Using also the same principle, you can see the airflow, the top surface of the wings is having higher curvature, so the airflow of the air mass is moving faster above the wings, so this creates an air suction that sucks the aircraft wings up into the air. So this is some of the forces you need to know when flying. the aircraft neutral stages and burn noticeably and other. So I will show you now the overhead panel and the systems to make the engine start demonstration very fast, and also the system display. So we go here, we have the overhead upper panel. You can see inside the cockpit here. Hope you like this view. So you can see we have these switches for disconnecting the hydraulics from maintenance to ground, the circuit breakers also. We can reset some electric system. We have here the electrical system, the APU. So you can see the electrical, the hydraulic, the fuel system, the electronic engine control for the engines, the auto start, the bleeder, and the pressurizer. So this is the main systems. We can start here the APU like this. This is the APU start and small air auxiliary power unit. We have the thrust asymmetry compensator, the primary flight control computers, the ADIRO, the air data mixer reference unit, electrical, the battery, the APU generator, and this is the IDG, the great drive generator, left and right engine driving, the window heat, passenger oxygen, ground proximity, the hydraulic system. You can turn off the hydraulic pumps, you will see what happens. This is also the lighting system, the windshield wiper. So we'll see the fault coming up and the warnings also been displayed here. We have the hydraulic systems failing because we turn off the hydraulic, so you can see the alternate flaps, stabilizer with red is lost, the hydraulic pressure system, and now LCR. So we have a lot of systems failing right now. So we need to turn on the pumps, the hydraulic, and the engine driving, and the electric. So we have the hydraulics back on. This is also the fire extinguishers control, not for the engine, electronic engine control for the engine, the auto start system over here on and off. You can dump some fuel in flight to lose weight if you arm this switch and select which tank. This is the left wing and the right wing fuel tank, and the center tank you can see it's empty, so this is the fuel system. You can turn on and off the crossfeed valves to balance the fuel between the left and right wing, and also wing and engine anti-ice. Over here we have the cabin pressurization. You can set the bleed valve, the outflow valves. If you want to use the manual, you have to turn on and off as you climb the descent to pressurize the cabin. And we have the bleeder from the left to the right engine, and the APU. We need the APU to start the engine. So if we turn off all the bleeder system like this, you will see some warnings here. You can see there is no bleeder from all the system, bleed isolation. So we're gonna lose the hydraulic pressure demand, C1 and C2, and also no cabin pressurization here. So we need also we cannot start the engines like this with this configuration. We need the pressurizer from the APU. The APU is small auxiliary power unit. We need to start the engine. The ground, we're gonna set also the flaps here. Flaps 15 degrees. So I'm gonna show you also this, the virtual cockpit. I forgot to mention this is the fuel control for the left and the right engine, the fuel flow. You're gonna see it in a couple of seconds. So we have one last thing left over here, the flight management computer and the display. We have the engines, the status, you can see all the systems. I'm gonna show you hydraulic, APU, oxygen level, at checklist if we have normal menu or no normal menu, communication, navigation, synoptics, We have the doors of the aircraft are closed, the cabin is depressurized, the landing gear, the temperature of the brakes and the pressure of the tires, the electrical. You can see the left and right engine, the IDG and the backup generators, the APU, also the main battery voltage, starts and restarts, how many volts we have in the battery. We have also the hydraulics, the left engine, right engine, C1 and C2, 3000 psi system with the hydraulic fluid course, which is used. The fuel system, left wing, right wing, center tank, you can see the excess is empty. The APU is fed from the left wing using the DC motor. Over here we have the forward and the aft pumps on, and the crossfeed valves on, also the low and the high pressure fuel valves in the left and the right wing engine. The total fuel on board 1000 kilograms and minimum fuel temperature below which the fuel freezes. Also the left wing, right wing, the leader pressurizer, we need from the APU to start the engine started, the left and right. You can see if I move the thrust levers forward, now we have pressurizer from the engine is increasing. So we have also one last the last over here the flight controls. So you can see all the flight controls are working like this. So if I move around all these things here and here and the other side, you will see the movement here. Everything is working, the wings and the tail of the aircraft, also the trim stabilizer, all the flight control surfaces. So go back in the engine, need to make an engine start demonstration. Start. So we're gonna turn off the engines, we turn off the fuel flow, left and right engine. You're gonna see a reset happening in the overhead panel. Also here the engine CN1 is decreasing, engine shut down. You can see engine shut down over here. And we can we have the engine start, auto start off. We need to turn off the auto start like this. You're gonna see engine auto start now. Maybe take right. There is no fuel flow. You can see both right and left. There is a pressurizer increase, so we need to let the fuel flow on both left and right wings. Engine, so we're gonna have the fuel flow increase from 0 and the N1 and the N2. You can see both spinners of the engines, the front fans are turning faster and faster, so we have the engine start normally. Both engines start, and we have the electric power back again. One last step left. Flight management computer, the menu, FMC, position, initialize, Lszh, Z8, 0 fuel weight, gross weight, reserves 5%, minimum fuel temperature and the cost index 100%. The route from this airport, LSZ8, copy paste back into this airport, runway 14, departure, select this departure and this arrival, LS14, next page, make key legs. So this is the route of the aircraft. Activate and execute. The route data, flaps for takeoff, center of gravity, calculate automatically, and the takeoff speed calculation. So we have the route here with purple is active, so you can see over here we have the complete route of the aircraft, like with this symbol. So we disconnect over here the parking brakes and we can taxi for takeoff. So we're ready for takeoff. Parking brakes off. You can see the parking brakes up and down. To increase the thrust, we take the clearance to takeoff from the air traffic control and depart. We use also these. So we have the runways open for us. We have the clearance from the air traffic control from the tower for takeoff. So we are here. You can see the scan from the radar also. We are aligned with the runway. So you can see where we are and where we are going right now. I'm gonna take VTU for takeoff also. So this is the scan of the radar. You can see the flaps are set for takeoff. The horizontal train stabilizer. We advance only the thrust levers. We have the thrust over here commanded for takeoff. So we disarm the parking brake. Align with the rudder pedals like this. And the nose will turn. So we have more thrust, 70 knots, 100 knots. So we have V1, we rotate slightly, and V2, and here we go. We have the positive rate of climb with the aircraft as we take off. Landing gear is up. Positive rate of takeoff, and pitch down the aircraft a little bit slightly. Not climb so fast. So we have the maximum continuous thrust to takeoff. We have the airspeed 203 knots. We are 2,200, 2,300 feet above the ground level, but 4,200 feet above the sea level. We climb with 5,900 feet per minute. This is the target airspeed, target altitude. You can see also the stall speed we need to avoid this warning, and you can see all the information in the navigation display, like the flight plan is correct. So we need also start turning, going into the turn now as we climb. We need to pitch up a little bit now. So we have about 14 more minutes left for this flight. For this video good. This is the airspeed right now as we climb. The stall speed also. So the outside view over here. You can see the vehicle in Switzerland. Also the star sign. in the view of the Boeing 737. So we're gonna follow the route for after climb. So now we climb with about 600 kilometers an hour, 250 meters per second. It's our airspeed. Keep climbing, 12,000. $13,000, 14,000 feet. $14,000. So you can see the stall over here is very close. We are flying with 153 knots right now, so we have to level off to increase the airspeed. Stop the climb for a while. You can see the indications here, and the engine indication. The flight management computer also here. The route and the autopilot radar system panel. Set for after climb, we have to follow this flight path waypoint. GUSTY to Alpha, you can see where is it? It's for 3.9 nautical miles away from us. Also, if we keep climbing like this, so we are 19,000. Climbing. Select the flat shot, increase the airspeed. So we have the France on this side, the Germany in front of us. And also use the airspeed over here. So we're gonna have the France, the Germany, the Bayern Munich in front of us, and the Switzerland on this side. So we are 32,000. Close 33,000. Maximum thrust now. So this is where we are. We have the handrails and the contrails over here. We have the frozen vapors and the galaxy above us. So you can see the Germany, the Bayern Munich on this side. and the front also. So this is a beautiful view of the Boeing 777-300ER, and also the lake in Switzerland. So you have the Bayern Munich, like 18 nautical miles in Germany, front of you, and the France on this side, and in Switzerland. So we need to start going back into the airport. We have to cross all the fixtures, and we need to keep climbing. So we keep climbing. We can see we have some aircraft flying very close to our aircraft right now, as we are airborne. We keep turning manually right now. We're flying manually. So we cruise here at 35,100 feet. So we cruise with about 900 kilometers an hour, 300 meters per second. So this is our spacecraft for tonight, the Boeing 777-300ER. Have this magnificent view over here, and the frozen vapors, as you can see. And we need to stay back to our home. We have also the lake here in Switzerland. So we're going back inside the cockpit. Set this autopilot on. So we have now the autopilot on connected here. So we're gonna have to start descent in a couple of minutes. Set also the information for arrival over here. So we're gonna be flying the steering waypoints like this. So this is our spacecraft for tonight, the Boeing 777-300ER. We're flying with 300 kilometers an hour, and decrease the airspeed, and also the vertical speed over here for descent. So we're gonna have a descent now, and also this is gonna give us over here, as you can see, we're descending to the 3000. We have the idle thrust here, and the information about the autopilot director system panel. So this is our descent now. Now we do expand, select the airspeed line. and also flying manually now. And we're gonna have the approach. And the flaps extend, Polani. So we're gonna have to be following this over here. So we're flying manually right now. We are almost aligned with the runway. And we have one more minute to go before the second. So we fly manually, we have the flight controls in manual mode. Also we have the Lszh localizer here, the information. You can see in the navigation display we are aligned with the runway and the glide slope. And we have one more minute for the video to end. So we need to advance the thrust levers. So we are here in the runway, flying manually, as you can see. Also use the ailerons and the spoilers, and the rudder pedals, manual thrust. So we have and here we are, just touchdown, parking brakes and reverse, full reverse thrust, full reverse.